Hello, welcome back. Today we are going to be talking about basic C syntax again. We're going to be covering some things we left out in our last video so that we can get started in our next one on some more advanced topics. So let's get started. We are going to start by talking about the C preprocessor and the preprocessor directives. The first one being the include statement. This allows us to include, basically link together other C files and our header files into our file that we're using so that we can access the functions, the variables, everything from the file that we're including, assuming it has global scope. This is pretty powerful, especially with pokeemerald. It allows us to split everything up into a bunch of different files, so we don't just have one giant file that's thousands and thousands and thousands of lines long. Now, we still have files that are thousands of lines long, but it would be a lot bigger of a problem if we did not have include statements. If the two files that you are trying to include together, link together, and not in the same folder, you have to provide the actual, directory path to the file that you're trying to include. But other than that, it'll link the file together so that you can access the functions from one file in another, the constants in one file in another. These are two examples from pokeemerald, the flags.h, which holds all of our flags, all of their definitions, and the constants.h also holds a lot of important constants that we use in the pokeemerald decomp projects. So that's include. Now the next preprocessor directive is define. This one is very powerful. It's not always used in a powerful way, but it can be. So basically what it does is it replaces the name that you are giving to the define statement. So we are writing define species mudkip. So species mudkip is being defined as 4. So anytime we write species mudkip anywhere, this is going to be replaced with 4. And all of this is happening in our preprocessor. So when we go to compile our C script to run it, when we compile our pokeemerald, our compiler, AGBCC, takes all of the C code and it compiles it down into the machine language that our emulator and our GBA can understand. But before that happens, the preprocessor is called, and it handles all of the preprocessor directives, and before any of this happens, these are replaced. Our define statements are replaced. So before our code is compiled, this gets replaced with a 4. So when our code is being compiled, the compiler won't see species mudkip. It'll just see 4. So you have to be careful when you are defining things to make sure that when it goes to compile, that you're going to have accurate C code. And we'll see why that can get complicated with this one. So these first two are just replacements for integers, but the second one, we can actually define this for all to be this entire statement. That's why defines are so powerful. They're macros. We can replace for all everywhere in the code before this compiler runs, and that's the important thing, because if this was after that, this would not be possible. But this for statement here, this just front of the for statement, is copied and it is pasted right here before the compiler runs. And then we have a legal for statement when the compiler is running. The compiler just sees it as a completely legal for statement. There's not a ton of reason to do this with, this for statement here. There are even worse cursed defines that you can do. You can replace the curly bracket if you wanted to. Sometimes in modern C it'll give you errors, but you could replace the curly bracket and the other curly bracket with begin and end, and you could completely change the way that you were coding in C, how it would look, and you don't want to do that, but you could. So the define statements are pretty powerful. We can use them to insert a lot of things into our code. We can use them to just handle our regular constants that we want to just to keep all uniform in one file. And we don't want to have to do lookups for our variables, because that's like, if we used an integer variable for this for our species, every time we wrote species mudkip inside of our program, we would have to look inside of the reference for the integer and call it, basically take out the value. Whereas when we're using our preprocessor directives, that doesn't happen, because for is actually just shoved into the code before it's compiled. So it's there as a constant, as a integer value, not as a variable that has to be accessed. So in that way, it saves time when accessing constants that don't have to change. They're going to be there. The species are the same all throughout the time, all throughout the your code. Mudkip never changes places in the Pokédex. So that is preprocessor directives. We now are going to move on to one more operator that we left out in the first video, and that is the modulus. So when we talked about integer division, we talked about how if the integers don't divide evenly, it will just get cut off. It'll round down to the lowest integer, and that is intentional. And we have a way to access that remainder, which can be very useful for a number of different reasons, and it is the modulus. And basically, we just use it instead of the division, and it outputs the remainder instead of the whole number division. So if we're dividing 5 by 3, which is what's happening here, so in this integer declaration, I wrote it this way to show how there's a little bit of flexibility with this that we didn't go over in the first one. I am actually defining 4 different integers here. I'm defining right, and then comma. I'm defining division, but it's not being given a value. Top is being given a value, and remainder is not being given a value. So right is just equal to 1 plus species mudkip, which we defined as 4, so this is just 1 plus 4, so it's 5, and then top is 3. A little messy, but I just wanted to show that you can actually declare your variables like this in this order if you wanted to, although you would obviously want to clean it up. This isn't good code. But when we do the division, 5 divided by 3, 3 goes into 5 one time cleanly, so this is going to output 1. The remainder, right modulus top, 5 modulus 3, 5 modulo 3, it's going to output 2, because 3 goes into 5 one time, and then there's a remainder of 2. So we can use this to, sometimes we'll want to check to see if something evenly divides another number for various reasons. So if you wanted to see if a number was even, you would write like the variable var modulus 2 is equal to 0. So if there is no remainder when you divide by 2, we know that this is an even number. Obviously, that's the definition of an even number. So if there's no remainder, then we can do, like, if it's an even number, we do what we have to do if it's an even number, and then you could do else if it's an odd number, whatever. So the modulus operator is pretty important, so we definitely want to cover that. And the next big topic that we're going to talk about is arrays. So they're our next data type that is pretty important. We declare an array just like we declare a normal variable. We start with the type of array. We can have multiple different types. There can be ints, they can be chars, they can be floats. So we start with the type, then we start with the name, and then the difference here is because we're having an array, we need to have a size of the array. Right here we're using this preprocessor directive for array size to define 3, but we can also just put 3 here ourselves, and that means that this array is 3 long. An array is like the name implies, it is just 3 values in an array. Now, an important thing about arrays in C, though, and in a lot of programming languages, is that they are 0 indexed, which means that when we are accessing them, we start with 0 instead of 1. So the position 0, this 1 is in position 0 in this array, this 2 is in position 1, and this 3 is in position 2. Because this is the 0th position, this is the first position, this is the second position. They start at 0 when we are accessing our arrays. Like here, this is how we actually access the array in the code. We, in the same way that you declare the size, we are accessing the 0th element, or the first element, or the second element. If we tried to access the third element, we would get an error because we do not have a third element. This would be out of bounds for us. So we can only access 0, 1, and 2. For this array, obviously you can declare an array of 100 if you want, and then we would be able to access 3 if we wanted to. We could access 60, but you couldn't access 101 because that would be outside of the array. So you can declare an array, you can initialize it immediately, giving it a value right after you declare it if you want to, or you can just declare it on its own and then give it a value later, like I do down here. Now, again, the array size is immediately switched with the value 3, so it's just 3 plus 3 is equal to 6, so this is an array of 6. Now we also have multi-dimensional arrays, so if you wanted a multi-dimensional array, it would be similar, but instead of finishing it, we just add another dimension. We can add a third dimension if we want. So here is our multi-dimensional array, and they are accessed in the same way, and you can store data in them exactly the same, like this. And you can, put something in this. You can put 3 into on the first row, second column, third, like inward z dimension. We are going to put that as a 3 because this is a 3-dimensional array. So you can also, put them together up here if you want to, just like you can declare the whole array in the same way if you need to from the start. So that is basic arrays. We'll obviously talk about them more as we go on, and we talk about some of the more advanced data types. So next we are going to talk about the continue statement, because when we went over looping in the first video, I kind of brushed over continue and break and return, so we are going to cover them and then also point out a fact about array indexing that we can use with looping and other things like that. So this for loop is pretty much just, our standard for loop. We are declaring our integer. We are going to keep running as long as I is less than the size of our array, because we want it to be, we are going through our array in this for loop, so we don't want to exceed our array. Like I said, if you access a variable outside, you will get an error. So we don't want to access a variable outside of our array, and then we keep going through our array 1 by 1 by 1. So this if statement says if I is equal to 1, we will continue. Otherwise, we are going to do this function. It's just a random function, just called add damage. It's not anything that actually exists. And then we are going to pass it our array, but we are going to pass it the value, the ith value of the array. Now this I changes. It starts out at 0, and then it goes to 1, and then it goes to 2, and then the for loop ends. But if we change this, it would keep going to 3, 4, 5, 6, 7, 8, 9, 10. So we are accessing the ith value depending on the loop, and it's going to change. So it's going to iterate through our array, and it's going to run this function with every value of our array, with 1, with 2, with 3. It's going to run this function. Now, if it's 1, because we have this if statement here, if I is equal to 1, when I is equal to 1, Instead, we are going to continue. Now, break would just jump us out. Continue jumps us to the bottom and then back up into it. So it basically just goes back to the top. It skips everything and goes back to the top. So it's a little different than break. I mean, it's a lot different than break, but it allows us to keep going through our code without running the bottom stuff. If we had stuff that we couldn't skip for some reason, but we didn't want to break all the way out, but we wanted to loop again without running this. So in this case, we just don't do add damage on the first index. So we only run the function on the 1 and on the 3. We don't run the function on the 2. Just arbitrary for this example, but there are actual reasons why you would want to do something like that. So that is the continue statement and array indexing with loops. The last thing we are going to talk about that we didn't mention before is scope, and that has to do with whether a variable is local or global. If we declare a variable outside of any functions, outside of our main function, outside of any of our individual functions that we write, just completely outside of any brackets, like down here, but you do it at the top. So if I declare a variable up here, int a, this is a global variable. This variable can be accessed from any function in our file. It can be accessed from, if we include this file into a different file, it can be accessed from that file. This is a global variable. But our, and it only is, it is initialized once, and if we give it a value, it's only given that value, it's only assigned that once. But if we are initializing a variable inside of a function, it is a local variable to this function. Every time this function gets called, it's going to initialize this variable again and again and again and again because it is a local variable. So to change that, to fix that, we have to give it the static keyword, and this allows it to not be initialized again. It changes it to global. So in this function, if we call this function, it's going to initialize banana and orange to both be 1, and then it's going to plus equals 1, both of them. So it's just going to add 1 to both of them. When we run it the first time, 1, 1, and then they go 2, 2. Okay. When we run it the second time, this is going to be 2 already, and it's going to skip this because it's static. But this one is not going to skip, it's going to go back to 1. So we're going to have 2, and then we're going to have 1, so then it's going to be 3, 2, and then we go through again, and then it's going to be 4, 2, and it's going to stay at 2 for the orange because it's always going to be coming back to 1. Whereas with the banana, it is a static variable, so it does not. It maintains its value throughout, no matter how many times the function is called. So that is the static keyword. I think that's going to be all for this video. We will continue on our next videos talking about C syntax with some basic binary, and we will go over structs and enums and pointers. We will see you on the next one. If you have any questions, if I skipped over something simple, if I forgot to mention something, or if I made a mistake, be sure to leave a comment and let me know. Otherwise, just have a good one.